Welcome again to another episode of the Southwest Climate Podcast. As always, Mike Crimmins.
Hi, Zach. How are you?
Happy holidays.
Happy holidays.
This is the December holiday edition.
It is. It is. Hot chocolate, ugly sweater on.
What are you getting your boys for Christmas?
Legos. It's always Legos.
Legos?
It's just easy.
Not an R coating for young boys?
Well, that's in the stocking. Yeah, it's definitely. You got to start them early. I got a lot of work for them to do. Let's just put it that way.
You got to prep them to either be, a starving artist or a computer programmer. Those are the only jobs that are going to be available.
That's true. I better take note of that.
Well, pretty soon I'm going to be artificial intelligence out of my job. So.
Well, the podcast will be taken over pretty soon by AI, I'm pretty sure.
Ben's going to be doing these cut-ups from the 5 years that we've been doing this. And
we did talk about having Siri or Google do the podcast for us. We would just ask it questions one time.
Okay, enough of that. So we've got a month to recap.
Mm-hmm.
We'll go over the climate. We'll revisit October a little bit, talk about November, focus a little bit more on the snowpack situation as we head into the winter. That's a critical resource to monitor.
Right on.
And we'll talk a little bit about the El Nino event and the forecasts that have been made for the Southwest. What do you think? I'm
ready. I think this more snow, the better. The more we talk about it, the more we dwell on it. The Snow-tacular episode. I can work that in as many times as I can. Worked hard on that. I workshopped that a lot.
Please don't.
Okay,
so let's just do a little recap. October and November was, for a lot of Arizona, sort of a whipsaw.
Yeah.
October was very wet.
It was.
I believe the southeast part of Arizona exceeded, I don't recall the exact value, but it was in the upper, fifth percentile in terms of precipitation. November, however, completely different story.
Yeah, not much at all.
In fact, it was in Tucson, the only rain event squeaked in right at the end of the month. Is that right?
That's right. Right at the close of the month.
What the heck happened? Why so dry?
We suffered through last fall. Do you remember last fall? We probably still have some trauma from thinking about last fall where we had the monsoon end in August and then we kept waiting around for September. Thought we'd get a tropical storm or something, but ended up having that September, October, November, and even December, even January, dry spell. And how warm November was and bone dry it was. This year, surprisingly, given how wet it was in October, having those tropical storms and all that moisture in October did not carry through into November. We didn't have a whole lot going on in November. Temperature-wise, though, was much cooler than we saw last year, which I think was a saving grace this year. I think it did help us hold on to some of the moisture that fell in October, maybe slowed down a lot of the drying that we may have seen with a dry month. But if you go back in the record, you poke at some of the stations and look to see how many times you zero out November, there's a good 5, 6, 7 years in the historical record that you've had zero precipitation. You can go to different stations around the state and see that. So November is definitely when we should be transitioning into that wintertime season, picking up some of those early winter storms, but it does not happen every year. And this year we just didn't see it.
Yeah, as it turns out, I do have that data handy.
Oh, perfect.
Yeah.
So I didn't have to just keep riffing on
making
stuff up.
You were right.
Well, all right, perfect. This is good. I'm glad.
It's surprising, quite
all
frankly. Right. So if you look at the historical record dating all the way back to 1950, there had been 5 years, more or less, with zero precipitation in November for the Southeast Climate Division.
Yep.
So this is the Tucson sphere of influence.
Right. I did that same exercise for Flagstaff and found you could see this for Northern Arizona as well.
But there's 13 years where they receive less than 1/10 of an inch.
Yeah.
So
it's not a wet month, right?
And this year
is that the point you're trying to make?
Well, I'm saying that it's not uncommon.
Okay, fair enough.
And so, if you stack the years and rank them, we received that one event averaged across the southeast part of Arizona was a little over a 1/10 of an inch, and that was 16th since 1950. And Tucson received a little bit more, actually, in that one event. End of November was, I think we got a little over 1/4 of an inch.
The buzzer beater right at the end of the month on I think the 30th.
But I was also looking back at the weather maps, and given that it was dry, I was expecting to see a persistent ridge that helped push our weather to our north and to our east, but that actually wasn't the case.
Yeah.
So what was going on, like weather-wise? Was it active? Was it, and if it was, what did we miss?
This was really good, right? We've had a very active jet stream since the monsoon season. We haven't had too many spells of being stuck under a ridge. And so if we think back to last fall, we had this sort of death ridge over the Southwest that just persisted. And being under that ridge, you're going to not only have the storm track pushed to the north, you're also going to be under the influence of those sinking air, warm atmosphere.
And hence the warm temperatures.
Yeah, so it's gonna conspire to give you above average temperatures, if not record. This year, we haven't had that issue. We've had a very transitory pattern. And if you look at the overall jet stream pattern over the East Pacific and then into the West and across the U.S., there have been some what we call centers of action where you see like a low or a high stationary, and we've been between that. So in being in between that, you can have
being in between a low and a high.
Yeah. So the pattern. So
where was the high? Was the high to our east?
You want more information than that?
No. Okay. No. Let's go.
I can't. I can't think about it right now.
I thought you had it at the top of your head.
I did
Mike,
not.
You usually have this stuff.
I did. I'm running about 65% right now. I mean, this is.
You got to drink more coffee.
Yeah, I'm working on it. I'm halfway through. About 2 shots into 4 right now. The
is that you really have 4 shots?
Seriously, 4 shots in there, man. Yeah, and it's
a little too much.
It's a long. I pull on it all day long, and so by about 3:00, I have a twitch in my eye, and I can't remember. I have no short-term memory, so that's actually.
Well, you don't need a short-term memory.
Apparently,
it's
not
like
working
Google.
for me. It's right. It's Google. Yeah. So there was a persistent low over the East Pacific, sort of mid-level. We call trough, leading to an upper level ridge over the sort of north central part of the country. And so what we ended up seeing was, and this actually relates back to the epic waves they've been seeing on the West Coast, is that there's been a long fetch in a low pressure system with a real long fetch into the West Coast that's just been spinning there for weeks. And that has just set up a train of waves that have been crashing into the middle of California. So what we've seen these little low pressure systems that will drop out underneath this trough and spin off towards the southwest. And so that repeatedly keeps any ridging from the south at bay and then keeps us into, kind of periodic cooling, or it just really helps moderate the temperatures.
But why then weren't we generating any precipitation from that?
It's moisture at that point. We just didn't, so if you're having these storms without real high latitude trajectories, if they're not coming right out of the Gulf of California, and if they do come out of the Gulf of California, they usually will have moisture with them and they're really cold. So you have this sort of trade-off. If you have a low pressure system and it's coming from high latitudes and it's bringing out its own moisture, its overall net moisture isn't very much, right? Because it's cold.
Well, and also has to traverse a bunch of land and a bunch of mountains.
That's right. And so for those to be low latitude precipitation producers, they have to maintain their coldness relative to their amount of moisture.
Wait,
right?
say that again. For them to be low latitude.
Yeah. So for them to bring their own moisture with them from a higher latitude, so they have to be cold, right? So if they moderate with that same amount of moisture, the vapor pressure deficit increases. What you want to have is if you're coming from a high latitude and you're bringing your own moisture, that storm system has to stay cold to be real close to being able to have condensable moisture and precipitation. So it's not until we get to the core of the winter season here that we can see these high latitude storms be able to
So it's a temperature issue.
Yeah, for sure. And so you can have these storms come down and they may bring clouds, right? That's what we see as you get this far south, is a moderating temperature. But they don't have enough moisture with them at that point to be able to do anything.
And the temperatures are too warm.
And the temperatures moderate. And
for the most part, maybe at the higher elevations in the Rockies.
Then. Sure. Yep. And then sometimes they'll drop, if they drop south and they're inland, it's real tough for them to produce precipitation. They'll typically dry out, but those can be our real cold events. If they drop down the coast and are able to then do this hook towards Southern California they usually pick up a little bit of moisture.
So that's the key. If they're coming down the coast and they're actually able to entrain more tropical moisture, and so it's not just the moisture that's coming from the north.
Yeah,
it's actually picking up some moisture from the tropics.
Yeah,
but if they're not coming down the coast and they're coming more in the interior, they don't have the same sort of trajectory that can pick up the tropical
Absolutely.
moisture.
Yeah. And so the Weather Service has this great term called an inside slider, is that you have
Sounds like a baseball.
It is exactly a baseball analogy.
Term.
It is a baseball term. Yeah. And you can have these storm systems drop fully inland. So they're just fully interacting with continental air masses. And so, continental polar air mass is going to be dry. And so you can end up having a wonderful, deep, cold, low-pressure system drop through the Southwest. And it'll be one of those where it's windy on the front end of it and it's cold and dry on the back end of it.
Okay, so then the question becomes is why do you get these inside sliders versus the storms that track more into the interior of the U.S.? So what's the sort of synoptic or regional pattern that sets up that sort of enables those inside sliders?
I think it's the upstream jet stream position and orientation.
Upstream meaning west.
Towards the across the whole East Pacific. And so this time of year, as we're sort of moving into the core winter season, we're looking across the entire East Pacific from the tropics all the way up into Eurasia and even into Siberia to see what's coming. And then this is where you get into the whole discussion about the tropics with El Nino and how they can either enhance or strengthen and shift that jet stream position or not. So we've got a couple different mechanisms to give us those great winter storms. So as we were talking about, having one of those low pressure systems at a high latitude, strong cold system drop down the coast and interact with subtropical moisture. So not only bring some moisture with it, but also interact with some subtropical moisture. Those can be very strong dynamically because they end up having real strong temperature differences with the ocean and the land masses, as well as now having moisture. Mm-hmm. So those can be the ones that are the great winter storms for us. And then we also have, the ones that we saw like later this month with this stationary low.
The ones that we saw later.
Later in November and then the early part of December, which are two rain events.
I thought you were already forecasting.
I'm going, man. I'm going full on. Enso all day, baby. This quasi-stationary low south of Gulf of Alaska off of the west coast, we had little lows spin off the bottom of it, and they were able to interact with some subtropical moisture. So it wasn't ideal, and we had real high snow levels. These were not, super duper cold early winter storms. They did produce some higher elevation snow. They were mostly warm rainers. We ended up having some pretty high snow levels, but very typical, very seasonal.
Right. So that event the most recent event, since November, there's only been two events for the most part.
For the most part,
the one at the end of November.
They're kind of, and they had
small
a slop over on either sides.
And then first week, I think it was December 6th, 7th, that at least for Tucson area was actually in some places close to 3/4 of an inch.
It was way wetter than the forecasts. The forecasts coming up leading into that event, it was this little filament of subtropical moisture that the low that was coming in off of the Pacific that was the question in the models was it going to pick up that little bit of subtropical moisture? And the models kept moving it to the northwest and then to the southeast, and it kind of went back and forth. And then the later model runs ended up having that stripe of precip to the southeast of us, which can often happen, is that subtropical moisture, as these things drop low, you can end up having real good wet conditions in Sonora, and then they go off into New Mexico, and Arizona's on the dry side. We've had several winters where the El Nino signal ends up cutting the Southwest in half, where New Mexico ends up having this wonderful, and Sonora does it, and we were like, wait, what? We didn't get anything out of it. This, on the weather scale, though, this event ended up, we dialed it in. That precip came right through, and it was much heavier than forecasted, too. Yeah,
and that 3/4 of an inch in Tucson basically represents close to half of the total monthly precipitation.
That's the way we do it in the Southwest. We don't mess around with it's 25 events in a month or something like that.
Well, okay, so that brings me, I'm looking at, plots that you have created, your cool season scorecards.
Cool season, man.
You've got the time span being between October and the end of May. And for Tucson, historically, in that period, 1, 2, 3, 4, 5, 6, 7, 8 months, I'm using my fingers here, 13 events on average.
Yeah, isn't that crazy?
That's totally crazy.
Yeah.
Just not that many.
Looking at that period of time, so it's, October, we've already talked about this. October, that weird, could be tropical, mostly not, mostly blank 0. And then that later part of April and May for Tucson, not a lot usually going on. So usually those events are happening right in the middle.
Yeah, that's true. The end of the month there, the end of that time span is basically 0. But even still, 13 events in those 6 months.
Yeah, we have more precip events in a shorter amount of time during the monsoon than we typically do during the winter.
Okay, so the other thing that I did, just to remind myself the climatology, was I looked at the climatology, or the average monthly rainfall for the southeast part of Arizona. And so October, on average, receives about an inch. November, about 3/4 of an inch. December is about 1.25 inches. January is about 1.25 inches. February is about 1 inch. And March is about 1 inch, and then it plummets. There's not much difference between the months. For one, it's 1 inch here and there. And if you miss one storm or you get an extra storm, it can make or break you in terms of percent. And it's also interesting when we look at the monsoon and contrast this with the monsoon. I mean, we really have two months in the monsoon that produce close to 3 inches. So, yeah, it's quite an interesting climatology here in the Southwest.
We kind of talked generically about the winter wet season and the summer wet season, but they are not like each other at all. they really are. I mean, mechanistically, the summer monsoon is so dramatically different than the winter. And then the winter expectation, this winter wet season, all the distributions, if you look across the state, they all have long tails to the right, meaning that in that historical record, we've got a handful of very wet winters, but a lot of dry winters, right? And so the averages end up not being all that meaningful in our expectations. Yeah, which is going to be great for when we bet on what those totals will be.
Well, I hope you have your estimate handy.
I'm
still thinking about mine as I'm going through these numbers.
I know we agreed on that. I don't even have a starting point on where we should be going.
So the other thing that was interesting is, as it turns out, when you look back over the last 100 years or so, about 33% of those years, December had the most rain out of
that. Surprised me.
I would have thought it would have been maybe February or January. Mm-hmm. So I'm wondering why mechanistically. Why would December be the hot month in terms of rain?
Yeah. The hot month in terms of rain. That is really confusing for a climate podcast.
Well, people can handle it.
Okay. I had to think about it for a second. I don't know.
Should I do some more mixed metaphors?
No, I think it's wonderful. I think you should stir in a sports one and maybe a cooking one too, if we could try to do that. So I was surprised by that. I mean, and I think you and I have talked over many years now about the core months for El Nino relationships is really January, February, March, and even like sort of February, March, right? So I think that then maybe it at least biased me towards thinking that those were the wettest months in our sort of historical distributions, and pulled up a couple of plots here too, and they're not. They're just what you said. There's actually more extreme variability for Southeast Arizona in December out of any winter month. It approaches on the high end some of the higher end monsoon totals, which I was quite surprised about. The variability,
yeah. Not the absolute value.
No, not the absolute values. Yeah. No,
the range is there's greater spread in December than in any other month.
Any other month for Southeast, and then if you look at the northern part of the state, it's not December. It's actually January and February.
So it switches a little bit.
It switches a little bit, right. So maybe it has something to do with the trajectory of the events and its access to moisture, like that early December event for the southern part of the state. Because if this is indeed the case, what we're seeing in the state is that the southern part of the state has more extremes in December. Maybe these storms that can reach low latitudes can pick up some of the later.
The moisture in the tropics is more northerly.
Yeah, it's sagging south for sure, but maybe
right. But as it's sagging south, so therefore
it's gonna be further away from us the deeper we get into winter.
Exactly.
Yeah. So that could be the case. Whereas that's not as much of a case for the northern part of the state. And the early December event was definitely more focused on the southern part of the state. So there's probably an answer out there. And see, this is where the Ask Siri would have been really helpful, actually. I'm not sure we'd phrase that in form of a question. But
a couple other interesting tidbits. Just looking at the U.S. as a whole, the last 3 months were the second wettest on record.
That's amazing. Yeah, I had not been paying that close attention.
And it's largely driven by the Southeast has received a lot of rainfall. We were just back east and for AGU, and there was a big storm that happened right before that.
Yeah.
Not in DC, actually a little bit further north, but
then they had another mid-Atlantic southeast storm slide through there and just produce copious amounts of rain.
So it's been a pretty wet fall for the most part, and we'll have to see how the winter plays out.
Yeah. What about the temperatures on the fall season here?
For November, the temperatures have been below average as a whole for the U.S. and in the West, it's been right around average. But if you look back at, let's say, the last 3 months, so September, October, November, national temperatures are basically average. Let's see, and it's slightly above average here in the Southwest.
So that November kind of near average is super consistent with that circulation pattern we were talking about too. Is not being stuck under either a persistent trough or a ridge, which is going to stack up the days in the anomalies or the above or below average. We've been kind of rapidly cycling between warm-ups and cool-downs, and everything's been fairly moderate.
All right, so one thing that wintertime brings is snow.
Snow-tacular. Got it. Number 3.
Is that going to be the title of the podcast? I hope not, Ben. No, he's shaking his head. He's like, that's terrible.
I have so many more. I'm going to slide in here.
Okay, so we've been focused in that last discussion basically in Arizona and New Mexico for the most part. But if you look at the West, it's been, and looking at these sites that monitor snowpack, so snow water equivalent or the amount of water in the snowpack, there's close to 2,000 of them across the West.
Mm-hmm.
They're both automated. And then you've got these manual locations that actually people ski into and measure, which would be a really cool job.
I know, wouldn't it?
I'm in the wrong business. Get to ski every day in the winter. I don't know what you do in the summer though. Maybe go to Alaska and fish.
Yeah, maybe. Yeah, maybe you should go to the southern hemisphere, chase snow down there.
What were we talking about?
I don't know. Your vacation plans, apparently.
Okay, snowpack. If you look at the snowpack conditions around the West, it's sort of a mixed bag. You've got slightly above average conditions in the northern Rockies and Colorado, Front Ranges area. Although the San Juans, the southern southwestern Colorado is really dry there so far in terms of snowpack. The snowpack in Utah is more above average than below average, although it's a mixed bag. Across the coastal range from Northern California all the way up to Washington, the Cascades, pretty dry. The western pattern of precip maybe follows what we were just talking about with Arizona.
We say this every year this month. It's very early. It's very early in the snowpack season.
It is very early, but I would rather have above average.
Well, yeah, who wouldn't at this point? But man, oh man, give it some time. We also have had years where it's been above average now and has tanked mid-season. So I'm kind of the slow and steady on the accumulation curve here.
Admittedly, it is early.
Yes.
And maybe we can't draw a lot of conclusions yet, and we should wait for January and February to play out. The important date for water forecasts or stream flow forecasts is April 1.
Yeah. Yep.
Turns out that April 1 is the time when is it peak snow peak snow water equivalent in April 1, or is that just an arbitrary date that people use to forecast stream flows?
Both. And we should make the distinction too that April 1st works for every place except the Southwest. And peak snowpack for Arizona and New Mexico is typically March 1st or somewhere. It's actually before April 1st since we're at such a low latitude.
A recent paper from researchers here at the University of Arizona actually were able to quantify snowpack changes in the U.S., across the U.S., focusing both on the eastern part and in the western part.
Which I thought was really cool about that.
Yeah, because it's usually
all west. It's usually all snow-tell sites, which you talked about earlier. So they're able to do it for the whole continental U.S. at the same time.
Sort of a similar story. Like we've heard this before. Snowpack is one of the changes that are most visible in the observational record. I guess the narrative prior to this paper, which we'll talk about in a minute, but the narrative is snowpacks are getting less, particularly at middle elevations. that's changing the amount of or when water is flowing in the streams is moving up earlier. Anything that this new paper by Zhubin Zhen and Patrick Broxton and Nicholas Dawson that was just published in Geophysical Research Letters in December, anything that this adds to the story?
One of the exciting things about this paper was that the basis for it is a continental scale continuous data set of snow cover, depth, snow water equivalent, and snow cover extent. Prior to that, we have remote sensing, which can do snow cover extent, but it can't do depth very well. And we have to sort of try to figure out what the snow water equivalent is, which is that how much water is actually in a sort of unit of snow mass. And the fact that it's daily from 1982 to 2016 and for the continental U.S. allows you to see the dynamics of both the depth and the extent really vary. And then they went the further step of being able to, for each one of those 4-kilometer pixels, try to evaluate the role of temperature and precipitation either alone or together. And it found a lot of the same things that we would have expected.
Right.
But it's a much more nuanced take.
Well, and it also did it at a finer scale. And you mentioned this, like previous work was basically doing these kinds of analyses for either the SNOTEL stations that we were talking about before.
Right.
They're point stations. And those are located, in higher elevations on or northern slopes. And so it provides a representation that has a lot of holes. And this work actually was able to link it to other data sets in a rigorous way and actually make it a lot more fine-scaled.
I agree. Totally.
It does paint the same sort of picture, but I guess a couple things that I got out of it was that they also broke it up, just looking at the West here, they also broke it up by mountain range. Mm-hmm. So they looked at the Sierras and they looked at the Colorado Basin. And turns out that the trends for the April 1 snow water equivalent is there's greater declines in the Sierras than in the Colorado.
Yeah.
And that makes sense because, correct me if I'm wrong, but the Sierras are much lower in terms of elevation.
Oh, that's a good point.
They have a figure in the paper where it's like the amount of area at different elevation ranges.
I clearly skipped over that figure.
And for the Sierras, 2/3 of the area of the Sierras is at what they call mid-elevations.
Right.
I'm not exactly sure what elevation threshold that is without looking deeper into the paper, and I don't have that number handy. But Colorado, on the other hand, 60% of it is at high elevations.
Yeah.
So I think that the fact that the Sierras are seeing and their snow water equivalent values in April are trending much lower than Colorado is because of that elevation distribution. And the other thing that the paper highlighted, I thought, which was interesting, and I didn't know this, but precipitation there's statistically significant trends over those 82 to 2016 period. Negative trends in precipitation, statistically significant in the Sierras and in the Colorado Basin.
Yeah.
I thought that I didn't think the trend was significant. So that's partially what's driving it, as is statistically significant temperature trends.
Yeah.
So both of these things together.
Right. And
but I thought it was mainly just a temperature issue.
I think that was the interesting thing that at this point, I remember the abstract. I did read this paper, was trying to reinforce the fact of the importance of, we've got a broader narrative. Temperature is absolutely important. And what they find in the eastern U.S., it's not water limited. It's April 1st. This totally makes sense, right? Because it's a low elevation. It's sun angle. You get to April 1st. If it's cold, you can have snow extent. And if it's not cold, you won't, right? So it's fairly straightforward. You get out west, you have the elevational aspect that's controlling temperature as well as the seasonal aspect controlling temperature. So you have this sort of interaction of temperature as well as precipitation. And that 1982 through 2016 period, we know in the western U.S. and especially in the Southwest is pluvial to drought. So I would expect that you'd see some tilt of having more precip at the early part of the record and less at the later part. So it becomes a little bit of an not end member, mm-hmm. but a period of record probably issue on that. But I thought what was really cool is they showed the interaction, and they could, the variance explained in the changes in those snow cover metrics of temperature and precip interacting with each other. And you couldn't explain everything by either variable alone, except precip was the most important, but you had to have temperature in there to get more of the variance explained.
Absolutely. So it's good to do these papers, particularly if they're new data sets and they can, do it at a finer scale. But it's good to update the story.
Yeah, right.
A lot of the papers that I'm familiar with, are like a decade old. Mm-hmm. And the story hasn't changed, but there's some added layers to this. So it's worth checking out. Let me just go over the title in case people want to look it up. It's called Snowpack Change from 1982 to 2016 over the Crimmins, United States.
Easy for you to say.
Not really. I stumbled on that one.
One of the key points at the end of the abstract of the plain language summary too was pointing out that it's really important for us to understand snow dynamics now so we can understand how they may change in climate models going forward. And so we're at a real not great spot right now on our understanding of both snow dynamics. This helps a lot of sort of dialing that stuff in, but it really points out how much better our monitoring has to get and how some of the data sets we're relying on, like remote sensing, maybe aren't telling the full story. And so then like running them out forward in climate models is going to be a real challenge.
Absolutely.
Yeah.
And I think before moving on, the other maybe part of that nuance that this paper adds is because they have such a high resolution, it can look at it at these grid cells at 2.5 miles. Is it miles or kilometers?
It's 4 kilometers or 2.5.
Yeah, 4 kilometers. They're actually able to quantify, well, how many of those snowy pixels, as they call it.
It's Snow-tacular.
How many of those snowy pixels in a particular area saw statistically significant trends? And not all of them. In fact, the majority of them aren't showing statistically significant trends. And so then it's the geography becomes important. Where are they showing up and why? And I think that's part of what this paper is trying to get a handle on.
You start to then think about how hard snow is out here, is that it's the geography of the mountains and the shape of the mountains too. And it's, as you said, it's you're going to see most of your change in the mid elevations, right? The lower elevations are going to be real ephemeral, and the high elevations, which are well below freezing, won't show much interaction with temperature at all. So it's going to be in the middle elevations where you're going to see most of your temperature interaction. So kind of cool stuff. We'll definitely want to pay attention to it.
I want to be conscious of time here, but we forgot to do something. When we were talking about the rainfall.
Yeah.
What is your wintertime prediction, Mike? And this is going to prelude the CPC and the other climate forecast.
Even before we go into expectation?
So total rainfall, January, February, March.
All right. Let's do this. Okay. Tucson? So the normal for January for Tucson is 0.94 inches.
Oh, you're giving
I'm going to tell you. I'm telling you.
Wow.
I'm saying it out loud, man. I'm doing this for both of us.
Okay.
I'm going to go with 1.5.
Wow, that's a lot. Wow.
I'm actually feeling 2, but I'm holding back.
Boy, okay. So El Nino is forecasted. It tends to tip the scales ever so slightly toward wet. I think it's going to be 1.25. All right, February.
All right. Tucson, normal is 0.86.
0.75.
Oh, good. I'm glad you jumped on that. Your pessimism is creeping in. I'm going with a solid 1.
Wow, 1. Mike. All right, March.
Oof, March is tough.
Why is March tough?
Since I've lived here, has not been a very wet month. The normal is 0.73.
0.9.
Oh, really?
Yeah.
Okay.
This is like going to be a very
You feel like it's going to be a later?
Well, I think it's going to average, the 3 months will be close to average.
Interesting. But that means that 0.9 in March is wet. Yeah, I'm just trying to think of what kind of rain event can you squeeze out of March?
You got to squeeze some rain events. On average, it's 0.75.
Yeah, that distribution is a mess. Look at last year. All those T's. Those aren't even numbers. All right. How about 0.3?
I think you have a more interesting division here. It's like
you evened yours
starting
out.
Hot and they're mixing metaphors again. Starting hot and getting cool. All right, so you're 2.8 and I'm 2.9.
Oh my gosh! Oh no, we came out with the same.
But we're both above average.
That's not. Is that? How does that work?
Okay, so Mike, we're both bullish.
Yeah, we are bullish
on this winter.
Uh huh.
So what?
Not a lot bullish, but
So 114% of average for 2.9 or 2.8?
I'm sorry, that was 2.9.
So 2.9 is 114% of average. So we're both bullish, Mike. Let's quickly hit what the projections are or what the forecasts are.
The forecast is above average for JFM.
Is there any updates on El Nino? We're still, as far as I can tell, we're still El Nino watch. Very likely to be a weak to moderate event. It's not quite clear yet where that'll fall, and then also that the atmosphere is still sort of lagging behind the sea surface temperature, so we haven't really seen any of the atmospheric response yet, but people expect it to be that way. The other interesting thing about El Nino that I saw was looking at the Columbia University and the CPC's forecast. Looking out to the end of this year, they've increased the chances for El Nino to persist into next winter, and that would be a double dip. Anything?
So really?
Yeah.
I didn't see that. No kidding. Whoa.
So the IRI, Columbia University's International Institute for Climate and Society, which, is one of those groups that has written the book on seasonal forecasting.
Yeah.
They issue their forecasts at the beginning of the month, and then they readjust them in the middle, and that readjustment, they take on some expert judgment there.
Mm-hmm.
And there was a change in odds. They increased the chances that El Nino would persist.
That is so interesting. That piece of information makes me, this is a feeling now. That when we're on the El Nino side of it, we have benefited from that during the monsoon season and in the fall, right? So I'm already looking forward to next monsoon season. I don't even care what happens this winter now. I'm kind of giving up on it.
Wow. You're opportunistic.
I am so opportunistic. This is all very emotional for me. Yeah, I'm just looking for rain, basically at every corner. That's what I got, Zach. I mean, that's what I know too. The official seasonal outlook say I have a probability anomaly of a 4%. So it's a 4% lean into above average. It's not a very strong lean.
That is is that even a lean?
Okay, fair enough. Yeah, so basically it's
a slight tilt in the odds.
Yeah. So we break this down for Tucson. The chances of, based on this outlook for January, February, March total precip is 37% chance of it being above normal, 33% chance of it being near normal, and 30% chance of it being below normal.
So if you play with those numbers, there's a 70% chance that it will be near normal or above.
Yeah.
That's the way
I always like your...
That's the way it's a little bit easier.
Yeah.
Takes a tercile in 3 categories and boils it down into 2 and increases the odds in 1.
Right.
I mean, hey, that's a win-win if you ask me.
But it's a very glass, mostly full perspective on it. The problem is that the range of values from the lower bound of near normal to the higher bound of above normal is enormous, right? What that envelope of climate could be is everything from the wettest winter ever to a very not great winter for Tucson. I like that. Mm-hmm. I like that idea. I guess it's shifting away from below normal is somewhat encouraging. Well, there's not a lot here, folks.
And then going back to the climatology, with December being an important, the most important month, if you will, of the winter, a fair amount of this should be determined in the next month.
Yeah, that's true. There's a little. We got days left, and it's interesting. The shorter lead CPC forecasts all have wet for the entire continental U.S. They all lean wet, so it's apparently going to be an active.
For what period?
For the 6 to 10 day forecast and 8 to 14 is definitely on the wet side.
Right.
It's coast to coast.
There might be some event in our near future.
Yeah, and it's interesting that the short lead outlook over the next 2 weeks is below average temperatures. So to wrap up our Snow-tacular podcast here, there could be a white Christmas in parts of Arizona and New Mexico with this below normal temps, above normal precip. Should equate to snow.
Any parting shots, Mike, for Christmas, for New Year?
I hope you get Legos for Christmas. I hope you ask for Legos.
Having the name Zach, that Lego commercial
terrorized
me.
I'm sure
when I was in. Yeah. I think I was in like 6th grade.
So prime time. It's on YouTube. Yeah. You should have seen the sweater that kid was wearing too. Man, that was 80s personified right there. Oof, it was a cardigan sweater, buttoned up. Oof, it's rough.
All right. That's it.
Thanks, Zach. Have a great holiday. Have a good break.
Yep. We'll come back in a month and do a recap and talk to you all soon.
Happy New Year, everyone.
Cheers.
What'd you get?
I didn't do it. Just checking. I was checking email. No. So, anything you want to say about that?
Snow is good. Water's good. Drought is bad.